thank you, everybody. It's really great to be back in person. Joe and I were just talking about how terrific it is to see everyone. We can also tell if you really dislike the presentation, so we'll know to speed it up or slow it down. And we hope you'll feel free to ask us any questions at any time. One of the things that we've spent a lot of time working on and a lot of time talking about now that it's really happening finally are these mega constellations, these low Earth orbit satellites that you've heard about in the news. You see about incredible launches with rockets, and we talk a lot about the new space economy, especially with these low Earth orbit satellites. They'll be operating at about 450 miles above the Earth, or sorry, 450 kilometers above the Earth, so very low altitude, lower latency, much lower than geostationary orbit satellites. And that's going to bring a whole new capacity to delivering broadband communications to the public. And really the unheralded story of that is a revolution in ground infrastructure that needs to accompany all of the satellite infrastructure that gets a lot of the press. We hear a lot about the rockets, we hear a lot about the space stations, but we don't hear a lot about what would actually happen on the ground. There are two big pieces of ground infrastructure that you need to think about when you think about a satellite system. One, of course, is the handsets that go into that communicate with the systems, or the base stations that you might have on your home. It could be a dish that we've gotten used to seeing, like an 18-inch satellite dish that you might use for DBS. Or it could even be just an ordinary handset like you have in your hand today. So for example, the iPhone 14 is actually able to communicate with satellites as a kind of an emergency backup point of communication on MSS spectrum, mobile satellite services spectrum, that's outside of the traditional cellular bands. So there's a lot going on in the space, and we expect a lot of things to change. But there was a third leg of the stool, and we figured if there's anywhere that we could talk about that third leg of the stool, it's with the National Spectrum Managers Association, because it's so wonky that only we and you would really love it. And we think it's really critical, though, and it's a great case study of how to, we think, manage spectrum for greater and more intensive use. And that is the gateway Earth station facilities. These gateway Earth stations are essentially the backhaul and the front haul to and from the satellite. So if you're thinking about this from the satellite to the handset or to the dish, that's the last mile, if you will, or the last 450 kilometers. If all that traffic, though, has to be aggregated and sent back to the larger network, and that's going to the gateway. And you can't just have one, you have to have quite a few. And for these non-geostationary systems, which are satellites that are in movement relative to a point on the Earth, that is, they're sort of going around the Earth, they're not geostationary and orbiting at the same rate at the Earth, they're going about 17,000 miles an hour. So you're handing off constantly with these different satellites, maybe just a few minutes per satellite. And you're constantly doing that and constantly trying to maintain a connection. So these gateway facilities are really feats, truly feats of engineering marvel. And there are typically multiple gateway Earth station antennas. These are maybe several meters in diameter, and they're located at a fixed site. And so we wanted to talk to you about that infrastructure and about the frequencies that they use, because another feature and a critical component of this is that one of the key bands that these gateways use is actually shared with a terrestrial mobile service called the UMFUS bands. We'll get you the full acronym here. But it is really a critical band that's been exhaustively licensed and auctioned. So there are investment-backed expectations from terrestrial wireless licensees in the band to use this spectrum. And these are very powerful dishes with a lot of sophisticated electronics that are in the gateways. So we're looking at a lot of investment on both sides and a lot of flexibility in terms of where the gateways can be located, as well as where the terrestrial mobile infrastructure can be positioned. And so how that works is actually a very interesting story and what we're going to talk to you about today. But first, we wanted to talk to you about why you need gateways in the first place, and that's where Tom's going to come in.
So what is a gateway? Trey explained it. There's a little diagram here, shows a subscriber. In this case, I showed what's supposed to be a phased array panel antenna, sort of what the product SpaceX is currently selling. You know, the subscriber connects to the network via the satellite. The satellite has to beam back down to a gateway, and that gateway serves as the subscriber's gateway to all the services that the provider is providing, mostly internet service or interconnection to the PSTN if it's voice. And in order to serve subscribers, that satellite, you know, these are mega constellations, so there's tons of satellites. You think, you know, they should be able to see a lot of the Earth, but they are relatively low. I mean, 450 kilometers is, you know, it's low Earth orbit. It's about as low as you can get. You know, it's about the distance from here to maybe southern Connecticut. And it's not very far away. But in order to serve customers, the satellite has to see both the gateway and the subscriber. So both need to be in view. Now, there's a caveat to that. Some satellite systems use inter-satellite links that could be optical, you know, using laser beams in space, to connect multiple satellites so that the satellite shown in this diagram could beam an optical link over to another satellite that does have view of a gateway if that satellite doesn't have a view of a gateway. But that's an exception to the statement that, you know, the gateway or the satellite has to see both the gateway and the subscriber.
And just to pause on that for 1 second,
yeah.
I mean, if you think about it, you've got these two satellites moving at high velocity in space, and you're trying to maintain a pencil beam of a laser between two satellites. That's your essential point of connectivity. It's a pretty dicey proposition. So inter-satellite links are available, but as a rule, for most LEOs, you're going to need to have the gateway and the subscriber in view of the same beam. And then I guess the question is, how big is that beam?
Which beam?
For the downlink beam from the LEO satellite to the ground.
Yeah, so they're low, so you get less spreading of the signal, but they're using, you know, phased array antennas can actually make those spot beams relatively small, so on the order of 20 to 50 kilometers in diameter. But moving on, the multiple satellites can serve multiple subscribers and use the same gateway. And by the way, gateways usually have more than one antenna. There's just one antenna shown in this diagram, but they'll usually have more than one, and they'll serve multiple satellites at the same time, all pointing in different directions and using the off-axis gain as a way to control the interference. So they could even use co-channel at the same gateway facility. But the issues are that, you know, spectrum is a limited resource. You know, there's only so much spectrum. All the satellite users share the spectrum. So in a slide or two, you're going to see that you know, a sampling of some of the satellite operators, and you'll see that they're pretty much all using the same spectrum. And then if there's too many, you know, satellites or subscribers using the same gateway, the gateway could become the bottleneck. You could have a capacity problem. So why do we need gateways? We need gateways to maximize coverage and capacity of the satellite system. So here's the slide I was talking about. So here's a sampling of some of the satellite systems that are out there: SpaceX, OneWeb, Kuiper, O3b, and Viasat. You know, they're all using Ka band for uplink and downlink. Some of them are using Ku band, the 10.7 to 12.7 and 14 to 14.5 for service links. Some of them use the same spectrum for both service links and gateway links. But all of these, all 5 of the operators listed here, use what Trey referred to, the UMFUS band, the upper microwave flexible use band, which is a mobile service in the United States. And so they all sort of overlap that. And for that reason, they need to show that they're not interfering, and there's limitations on how many gateways can be deployed in a single county. And so I'll move to you.
Okay, so let's talk then about the other side of the coin, the upper microwave flexible use service, UMFUS, as it's affectionately known. As you can see here, we've just shown some of the licensing profile in the different band, and there are multiple UMFUS bands. The primary one that the satellite operators have been focusing on of late is the 28 gigahertz band, because it's the lowest in frequency and the most well-developed. But there are these additional UMFUS bands that are also available for mobile deployment on the ground and available for fixed satellite service use for connections back and forth from the satellite. As you can see here, a lot of the bands are dominated by one particular operator or another. So the 28 gigahertz band tends to be a lot of Verizon licenses, as shown in the pie chart above. much the same with the 37 gigahertz band. You get a little bit different picture, a little higher in frequency. You start to see AT&T pick up, and then finally you've got Dish at the top there. There are, however, a mix of licenses at each one of these bands, even though one or the other tends to be dominated by a single operator. So often it's a relationship between a multiplicity of satellite operators, though, and one particular licensee with a very broad geographic footprint throughout the country. And so what works in one space may or may not work, depends on who your counterparty is, but you are liable to have repeat players at the table, at least on the terrestrial side, from geography to geography. Let's see if this works. Okay. So let's talk briefly about, okay, there you go. Let's talk briefly about the sharing model. We mentioned earlier that this is a different model than we've historically seen. Time was that you would have, when you talked about terrestrial satellite sharing, you would typically see satellite gateways in remote areas of the country where there were really no terrestrial users, and often it would be shared with fixed links so that you would know where the fixed links were, and there would be very large buffers around the satellite earth stations or satellite gateways so that they would not generate interference and they could not receive interference. As you can imagine, if you're going to communicate with something 450 kilometers away, it's got to be a pretty sensitive antenna, and of course to communicate at that distance, it's also got to be pretty powerful on the outbound communication as well. So a great risk of interference to others, a great vulnerability from signals that are in the area. And so you tended to have very large separation distances. The FCC said when they created the UMFU service, it was going from a fixed band to allow mobility. And as part of the bargain, they said, we see these satellites, these mega constellations on the horizon. We know they're going to need a lot of gateways. This band is harmonized in a large part of the world for these types of satellite gateways. Let's do both. So terrestrial licensees, if you want mobility, where all the money is, you'll have to tolerate these fixed satellite service gateway locations. Fixed satellite service gateway licensees, at the same time, you don't get full flexibility. You can't locate anywhere. We're going to put some constraints on you, but we'll allow you to select pretty much anywhere in the United States you want, subject to certain exceptions, the most important of which is there can be no more than, we will allow no more than 3 gateway locations in any county. And the FCC said we have more than 3,000 counties in the United States, 3 gateway earth station locations, plus a few grandfathered earth stations. That gives you around 9,500 sites from which to choose. Mm-hmm. But of course, there's only one New York, and there's a lot of empty territory in between, and a lot of the data centers are not necessarily where the available counties might be. And so that creates an interesting dynamic on the ground as the satellite operators vie for favorable locations that are near where their customers are and are near where fiber infrastructure and power and other critical infrastructure is. So the rules that the FCC ultimately adopted had these 4 basic parts. Just to recap, they did grandfather some satellite gateway earth stations that were already there. So it will ultimately be a little bit more than 9,000. They tended to favor these remote areas, but it's not exclusive. You can locate anywhere as long as you meet their criteria. The satellite operators did have the opportunity to purchase the UMFU spectrum at auction, and they chose not to. And so they still, though, have a secondary market. They are able to acquire licenses from Verizon, AT&T, or the other terrestrial licensees if they find that it needs to be done. It'll be a different service, but they essentially have the ability to take that out of the terrestrial portfolio and put it into the satellite portfolio. So far, no satellite operator has come and bought spectrum for that purpose. And so it'll be interesting to watch and see if that changes. And so the last part of the sort of functional perspective on these rules is that the satellite operators can, in fact, populate their earth stations even in highly trafficked areas of the country, provided they meet a host of rules, which we're going to walk through with you in just a moment. And so I think the critical takeaway for me is that whereas the old rules were static, These are very dynamic. Satellite operators can locate anywhere, terrestrial operators can locate anywhere, and the FCC is mediating the difference between the two with a very detailed set of rules, but not prescriptive as to the location or the frequencies or how these two are shared. All right. So here are the detailed rules. And I'm going to give you the flyover, and then Tom's going to give you the really detailed rules. The main section of interest is section 25.136 of the Commission's rules. And the idea is to protect the terrestrial deployments in the bands that I mentioned earlier, the 27, 47, 50, among others. And again, the satellite operators are focused on that 27, 28 gigahertz band range. And so the FCC allows satellite operators to position their gateways anywhere, except you can't be near a major event venue, an urban mass transit route, a passenger railroad, a cruise ship port, an interstate, an other freeway or expressway, or a other principal arterial. We'll talk about each of those, which are not always the model of clarity, as you might imagine. And while there's no first-in-time right, having a limit of 3 gateway locations per county creates a little bit of a foot race for who can get the first 3 in a given county. And what we're seeing is lots of applications coming in, and some of these counties do in fact have already 3 gateway earth stations in the county, meaning unless a new operator is able to co-locate with an existing site, which is permitted, that they're out of luck and they need to find another county.
If I could.
Yeah, sure. Go ahead.
So he's listed 3 bands here, 28 gigahertz, 47 and 50, or 51. Mm-hmm. 47 and 51 are secondary in the band, but nonetheless, they still have to make a showing that they're not interfering, and they still have the same limitations as in the 28 gigahertz band where the services are co-primary. So.
Excellent. All right, so here is a sample of a spreadsheet we have, we kind of maintain internally, about the UMFU's band gateways that are either applied for or that have been licensed by the FCC. This is just the first 10 rows of about 700 pending or granted applications.
It's a long way from 9,500. But
yeah, it's a long way from 9,500, but it is interesting that a lot of these cluster in particular areas. There's activity, and then there's inactivity. And so you do tend to see activity concentrated around what might be considered high traffic areas or more desirable locations. So plenty along the coast, fewer in the interior, and you can sort of take stock of where the opportunity for the satellite market might actually lie.
Places like Hawaii and Alaska where you need to have gateways, and there's a limited number of counties, so they're sort of bunched up in those places. I think there's a handful of counties that have 3 earth stations already, and a few more, maybe 10 or 15 that have 2. So we're getting to the point of saturation in some counties in the United States.
Mm-hmm. Absolutely. Okay. So a little bit about just how the coordination works. Obviously, we've got folks here who are generally familiar with the coordination procedures that might apply between 2 terrestrial licensees, but this is a little bit different. And it's probably worth at least pausing just on the mechanics here. They cross-reference Part 101, which lays out a certain process that I think is familiar, but there are some little tweaks here that are worth mentioning. You have to coordinate with existing licensees with either present systems or planned future systems. So you have to allow for the future, including growth that might occur among the terrestrial systems. So just because it's vacant now doesn't mean that you're entitled to ignore all of those things about passenger rails and major event venues. You still have to observe those restrictions as a part of the coordination process. Every satellite applicant has to complete the coordination process prior to filing. They can't say coordination is going to be coming, so they need to retain ComCert or some other party to actually prepare a very detailed survey that goes through every rule provision in 25.136 and maps out how they comply or do not comply. And then there's a interference avoidance showing, which Tom will get to in a moment. is that it can't exceed a permissible level in absolute terms. You have to commit to cooperating fully and resolving technical problems. And then you have available to you certain special procedures, shielding, among other things, putting up, relying on buildings, or even putting up containers and stacking them on top of one another to create a barrier for radio frequency emissions going outside of your gateway location or coming into it. And so that kind of shielding can be quite helpful, especially if you're in a congested or heavily populated area. All right, now.
Oh, now the fun stuff, the technical stuff. So, yeah, Section 25.136 defines a power flux density limit of minus 77.6 dBm per meter squared per megahertz. Now, we don't need to worry about what that means. It's a relatively low level of signal that is deemed not to interfere with UMFUs. And so they need to keep their PFD contour limited in size. Now, how do we calculate the PFD contour? Well, each Earth station has a minimum elevation angle as low as it can go. These things are tracking, NGSO satellites that could be anywhere, so they could have almost any azimuth, but they have a limit of how low they can go. When they're at their lowest elevation angle, the gain toward the horizon, or the power toward the horizon, is what is used to calculate that minus 77.6. And usually, as I said earlier, most gateways have multiple antennas. And if there are antennas that are going to be transmitting co-frequency simultaneously, then you need to take the aggregate power toward the horizon of all the antennas. And this drawing isn't to scale. That off-axis gain toward the horizon should be sort of, close to the level with the horizon. But the other thing is, the FCC didn't specify what propagation model to use. They just said use commonly standard propagation models. So different companies use different propagation models. You are allowed, and in fact encouraged, to include clutter if it does apply. If there is trees or woods or buildings nearby that are going to cause clutter, the FCC guidance guides you toward the ITUR recommendation P.452, which allows you to sort of incorporate clutter into your calculation, which will help to shorten up that contour, and it makes it a bit easier to meet some of the criteria, like not crossing highways or event venues or ports, or so it's a rather complicated calculation that requires some specialized software to do, because you can see the rule is that it has to be 10 meters above the ground, and of course 10 meters, the ground isn't flat, right? So 10 meters varies, and you need to calculate the PFD at a multitude of points and then figure out which ones are greater than minus 77.6 and which ones are less, and that defines your contour. And I think we have an example on a couple slides later.
Hop to that if you want.
Next slide. Yeah, go ahead. Yeah.
So put your
you're going.
put your contour up there.
Yeah. So here's an example of a contour. We'll go back to that previous slide in a minute, but this is I think a OneWeb contour in Connecticut, and you can see it's very uneven. Often there's resurgencies, or it's not just one polygon; it could be multiple polygons where the PFD exceeds the minus 77.6. But then we'll go back. Yeah, I think.
There you go.
Yeah, we'll go back. So the rules define the population that this contour can include. And it's the table is shown here. It's 0.1% if it's a very large county, greater than 450,000 people. It's 450 if it's between 6,000 and 450,000. And if there's fewer than 6,000 people, a very small rural county, it's 7.5%. And so that's the limit that all earth stations in the county can cover. And it counts actually if there's an earth station near a county border and the contour actually goes over the border. You're basically covering population in 2 different counties, or potentially up to 3 if you know.
Could be
if
quite
possible.
a few.
It could be more, yeah. And so those population counts count against it. So when you're doing this calculation, you have to look back at any pre-existing Earth stations and see what population they reported that they cover, and make sure that you don't cover enough to put you over one of these thresholds.
Put all the Earth stations over the threshold.
Yeah.
Yeah. Mm-hmm.
Yep. So yeah, and as Trey mentioned earlier, the rules say you can't cover any major event venue, urban mass transit route, passenger railroad, or cruise ship port. Usually those aren't a problem. Usually it's the highways that are the problem. And there's different levels. It's all the major roads of highways, but the FCC guidance said, you can't rely on federal data because states sometimes classify roads differently than the federal government does. So you need to also check the states, and that tends to complicate things a little bit because each state does things a little bit differently. And
yeah, I mean, not only do the states tend to classify roads differently, I don't think any two states use the same language either. It's not, so that one of those things that you have to avoid is other principal arterial, which I think is pretty rare in state lingo. And so you have to decide, well, does a state highway qualify as a principal arterial? Or what about if it's a two-lane road, but it has a lot of traffic? People can disagree, and it's not intuitively obvious.
Yeah. It's just a little wrinkle in the process.
A fun one, though.
Yeah. So, yeah, we're back to the sample, the contour example. Yeah, there we go. So, one of the things about contours is they don't necessarily conform with, boundaries that are defined by the Census Bureau or anybody else. And so there was a little bit of disambiguation about, or ambiguation about how to calculate the actual covered population. So as you can see, it's kind of easier to see the contour in the map on the left, but the map on the right sort of shows census blocks. And now census blocks are the lowest resolution that the Census Bureau actually generates in terms of when they count population. You know how many pops are in a block, but you don't know exactly where in the block they might be. And so if you're only covering part of that block, how do you figure out what pops you're calculating, or what pops you're covering when you don't know actually where the population is? So the next slide talks a little bit about that.
So the basic concern is everybody could be on the east, all the population could be on the east, and then the west is empty, or vice versa.
Right.
Yeah.
So to cover that, the FCC's guidance said you can use what they call the proportional area method, where you basically calculate, for example, if you're covering 25% of a block that has 100 people in it, then you're covering 25 people. You may or may not be covering 25 people, but there's really no way to know and no way to calculate exactly what you are covering. So it's an estimation that so far I think hasn't been an issue. But and the rounding. So of course, when you do my example gave an integer number, 25% of 100. But if it's 25% of 99, you have 24 point whatever. So you end up with these partial people, and so different companies. There's no guidance about how to round these numbers. So different companies do it differently. So some companies might do it block by block. My 24.9 people is 25 people. Some people might take the 24.9 and add it to the others and then round the number at the total at the end. And some people just don't round at all. They just say, hey, we're covering, 30 and a half people. So I'll let you talk about this one.
Okay, sure. This is a SpaceX gateway that's pending. It was filed on May 4th. And Tom pointed out this is the SpaceX headquarters, and it's got
facility.
Yeah. It's got the interstate in California right up at the top of the screen, and the very large buildings all around it, and the small-ish yellow circle is the contour of the proposed gateway Earth station that they would like to operate. Unlike the others, it's fairly compact and almost perfectly circular, and that suggests they're doing something either a little differently or they are using a lot of shielding. And in fact, I think both are true. It's, Tom pointed out, there are quite a few buildings around here that is helping them keep that fairly compact. And they're also applying a survey of the different satellites. This facility, they indicate, will support up to 8 simultaneous first-generation Starlink satellites and up to 32 second-generation Starlink satellites at any one time. But to get this circle, elsewhere in the document, they point out that they'll take a sample of what a point in time looks like at any given, what the emissions footprint looks like at any given point in time. And I think that that helps keep the emissions fairly low, keeps the contour fairly small, although frankly, we're still trying to sort out how they get their contour this compact beyond just shielding and other functions, because the FC, not having specified a precise method of how these contours are to be calculated, there could be some creativity in how you arrive at the actual figure. And in this one's in LA,
Yep.
and so it's quite a congested environment. And so it is imperative, if they're going to meet this population threshold and actually locate in LA, that they have a very small contour, because it's a desirable location. It's going to have the lowest population threshold for the preclusive effect of that contour anywhere. And so if it's not small, they're not going to have a gateway there.
I think in this case, they kept it to the compound or the campus of SpaceX, so there's zero population, right? Since
Right.
industrial area.
Pretty much, yeah. I think that was the total that they mentioned was like 99.99 people. So
Oh, okay.
I guess
I think in the south there,
the
it goes
Twitter
into
employees are sleeping there or something. But sorry, they So I mean, and that's probably because of the distributed population method more than anything. It probably is a zero population, and that may be something that they're going to keep in their hip pocket. That hey, it says that the distributed population is 99.9, but in reality, it's just a place of business, and no one will be impaired. And by the way, we control all the land around it, so even if Verizon wants to deploy, we have no intention of letting them onto our campus. So it could be a very interesting one to watch. But each one of these is kind of a tiny jewel box of coordination and engineering, and each one is different. And overall, I think it's presented a pretty interesting and dynamic way to coordinate very different types of uses in the same frequency. And so when we think about how this is going, we're about 4 or 5 years in from where we've started to see the first of these applications. We've got the question of, hey, is it working? And I think the answer is yes, at least from my perspective. But there are costs. There are costs in terms of the flexibility that the satellite operators have. They can't position these earth stations anywhere they want. They have to dance around event venues and railroads and whatever a principal arterial is, as well as a cost on the terrestrial licensee, because each one of these bands has to be analyzed by the terrestrial licensee, which takes time and resources to protect the rights that they've purchased at auction. So they've got to go through that exercise. But that, I think, in their minds was the price of mobility, and it was a price worth paying. So the terrestrial licensees have gotten the mobility enhancement, but they do have to engage and coordinate in good faith with the satellite operators that are trying to position these gateways throughout the country. They've already filed for 700, and I think there are several hundreds more to come. And so while you've got flexibility, there are compliance costs. There are these vague terms and terminology. There are these uncertain standards of how you calculate a contour. The FC has tried to keep it very flexible, but that flexibility imposes a degree of uncertainty and cost on other operators operating within this environment. And the last bit is it could encourage some speculative applications. As you can imagine, some of these areas like Los Angeles, it might be very desirable to have a gateway in Los Angeles because you might want to serve subscribers there. But if you do not have a gateway, you may not be able to serve Los Angeles. And so there are more than 3 fixed satellite service providers. And so who gets there first will be very interesting to watch. The other dynamic is co-location is available, but you've got to co-locate. And if one of them is on the SpaceX campus, they may not be willing to co-locate or make that land available to their competitors. So that'll be an interesting one to watch. How much of that is available to third parties? and is it available on an equal basis? So lots of interesting issues on the horizon, lots of them already under our belt, but overall it's a really dynamic sharing environment and one that is going to involve a lot of frequency management for many years to come. So with that, maybe we can pause. We'll take a few questions. I know we've thrown a lot at you, but it's a fun area and one we're really excited about.
I love the tiny jewel boxes. That's really nice. So I assume we have some questions for the crowd, from the crowd. Anyone want to ask? We'll start with somebody from Nokia.
Pat McKay for Nokia. Just a simple question, because I'm not super familiar with Part 25 rules. The co-location part. Someone comes in. Is there anything in the FCC rules that says you got to negotiate in fair faith, good faith, to actually do it, or can they say, "Don't even knock on my door"?
That's a really interesting question. I think it goes to the real property rights. If there could be all kinds of constraints. There might not be physically enough land to put another site in there, and so the FCC hasn't specified. I think it would be hard to sustain a refusal to co-locate if there's a vacant parcel right next to you, and there would be some expectation that you would negotiate in good faith to allow that operator to conduct business and put their earth stations up. But for some of these sites, it could very well be that there's just not enough real property to go around, not enough roof space or land available, or the Starlink campus, SpaceX campus, as an example, they just may not want to. The FCC hasn't talked about that, but I think the real constraint would be the real property, and there's this implied good faith element on the radio frequency bit, but that only goes so far.
Yeah, that'd be very tough. I would think they maybe put on a good face and then close the door and lock it. Thank you.
Yeah, absolutely.
Sure.
No, thank you.
Yes, I was just curious on the gateway side, the diagrams, I think you mentioned the flat panel phased array antennas are at the users or the household sometimes, presumably on the satellites.
Yep.
But is that technology advancing or useful at the gateway side, and does that change the footprint?
That's an excellent question. Yeah. Most of the gateways are using parabolic antennas currently, I believe, right? I haven't seen any non-parabolic gateway antennas. Yeah, that's an excellent question. Do you know?
I don't know the answer. I do know that the home antennas is where a lot of the innovation is taking place. Yeah. That those phased array antennas are, they've gotten smaller, they've gotten flat, and when you open them up, it's a wonder. It's simply amazing how many antennas they're packing into, the one consumer product. And the prices are really falling dramatically. So some of those first ones were thousands of dollars, and some of the next generation ones, they're really trying to get that price point quite low, much lower than that, so that it's accessible to consumers. And so I think it will be a mass market product on the consumer side. Yeah. But my assumption is, because I've also not seen anything other than parabolic, is for the enterprise side, they're not producing this nearly the same volume, and there are efficiencies to be had with the parabolic format. And so they're sticking with that as an end product.
I mean, my guess would be that you want to, obviously you want consumers to have a high performing antenna, and you want to put them on the satellite because they're lighter and more flexible. It could be that at this point the price point for gateways is just not low enough to justify it. The advantage of a phased array is it's electronically steered, within some range of angles. In SpaceX's case, their consumer equipment is both mechanically and electronically steered. I think someday, if the price point comes down, you may very well see gateway antennas being phased arrays. It just makes sense. It's better technology. But we haven't seen that so far. So.
You had noted that the 28 gigahertz UMFS band is co-primary with the gateways. But one of the conditions was not to block the future growth of the terrestrial systems. Being involved in some of the coordinations for that, what we've seen is an initial approval from, say, Verizon, but with a caveat. So how does that work into the whole planning and putting the gateways in, since you are talking about a significant investment?
So are you saying Verizon has put a caveat into the...
Not necessarily Verizon, as an example.
Right,
One of the UMFUS licensees
right.
tends to condition their clearance.
Interesting. I would think they'd be hard pressed to sustain that. So that's probably one of the UMFUS licensees that begins with V, being very cautious and wanting to reserve some flexibility for the future. But in my conception, the way it's supposed to work is you've cleared that contour. That contour is now yours, at least in the 28 gigahertz, as the FSS gateway licensee. And it is presumptively not blocking future growth of the terrestrial mobile infrastructure by having not covered a major arterial, an event venue, met the population criteria, and so on, not be more than the third Earth station in a given location. So if I were the FSS licensee, I would say our job here is done. We are not blocking your future growth because it's low population. It's fairly remote. It doesn't cover these areas of special consideration for mobile. But if I'm Verizon, maybe I cite, or an UMFUS licensee, I cite that little caveat that I put in my coordination statement somewhere, and I try to argue it. But I think that that's not a compelling position for them.
One thing we haven't mentioned is that a gateway operator can choose to be secondary. They don't have to be
That's a good point.
co-primary. So
yeah, and sometimes that can ease the negotiation. So if you're in a congested area, and the UMFUS licensee is giving you a lot of grief about, well, I really want to serve that cow pasture, you can say, okay, look, I'll go secondary. The risk is, of course, that they might be displaced down the road, but if you're pretty confident that they're never going to deploy UMFUS in that location, it might be a bet worth taking.
One other, you have one more.
The studies that are, Will Perkins with ComSearch, the studies that are going in are predictive, but don't you think the Earth station licensees are on the hook for the PFD that they actually produce? And you can see a benefit of doing a very aggressive predictive study to get in, and then, possibly covering more population than you expected to, or going across the road that you didn't expect to, and having to remedy something down the road. What advice would you give your clients on how to navigate that situation?
So my advice would be not to do a very aggressive study. I mean, I would think that you would want to, if anything, over-project your contour now, because UMFUS is not heavily deployed. And as long as you can meet these criteria, that you should take a more permissive approach, and then narrow in, because it's going to be harder if in fact your contour is a lot more challenging. It's doing you no favors, because you'll in all likelihood have to remedy it. They may be thinking, well, we'll shield it somehow down the road. But I think that an ounce of prevention is better than a pound of cure.
And just for the record, we're not representing SpaceX. We're not advising them.
Or Verizon.
Yeah.
Well, we could probably have a week-long conference on this. There's a lot going on.
There's a lot going on
There
there.
really is, and this is spot on. You guys are right at the heart of what we do in so many ways. So really, really appreciate you bringing these issues to the forefront. Hopefully, we can get a big round of applause for Trey.
Thank you.
And for Tom. Thank you. Trey, this is 3 years running now. You're becoming
Like a regular.
yeah. Holy moly! Watch
I
out.
know. Yeah.
3 timers.
Thank you, gentlemen. Really appreciate it. Really well done.